Hello students, in this video we are going to learn correlation and regression using Excel. But before we go to Excel, I'll just give you the formulae which we use in correlation and regression and the types of correlation and regression one should know. There are two types of correlations we should know. First is Pearson's coefficient of correlation, and if you have two variables x and y and you have the data, then you can use this particular formula to find out the Pearson's correlation coefficient. The correlation coefficient will vary between +1 and -1. +1 is the highest correlation possible, -1 is the highest negative correlation possible. Then we have another correlation which is called as Spearman's rank correlation. When you don't have the values, it's a non-parametric. When you don't have the parametric values and you have just ranks, then you can use this particular formula, which is Spearman's rank correlation. Here D is the difference between the ranks. And if you have the values, the parameters are already available, you can still use this by converting the values into ranks. So in the example I will demonstrate this. So these are the two types of correlations we are going to study. Then two types of linear regressions. We have only linear regressions in this syllabus here. So first is simple regression, where you have we want to develop a formula like y, which is a dependent variable, equal to a plus bx. X is the independent variable. So we have only one dependent and one independent variable. Then we develop this simple regression. Here a and b values can be found using this, but in Excel we are going to get these values immediately. Similarly, we have a multiple regression where we have more than one dependent variables and one independent variables. So suppose there are two dependent variables x1 and x2, then the formula will look like this. But again, we don't have to worry about this complicated formula because Excel will give us the multiple regression equations also immediately. So now let me take you to the Excel where we will be looking at all these four things. So this is our data. Data is with respect to say football matches and between the various competing clubs. And so the previous record shows that if the club has already had 4 wins and then they spend around that much promotion, then they can expect attendance of 36,300. Means they have witnessed attendance of 36,300. If the that particular club has already have 6 wins during the league matches and they spend around 55,700 as towards promotion, then they have witnessed around 40,100 attendance. Like this data is available. So we have three parameters here: wins, promotion and attendance. And obviously attendance for the upcoming match is going to be the dependent variable, whereas the previous wins of that club and the promotion which the club is doing or on that particular tournament is the two dependent variables. So first we'll look at the correlation coefficients. So to start with, we have here Spearman's correlation coefficient. So what we need to do first, because we have these parameters already available, we will convert this into the ranks, and with this we can simply use this. Other attendance also we will convert it into ranks. What we can do simply, how to do that, I'll just show you. Just select this and then use, means earlier you will not have ranks. How to get to the ranks? So suppose you want to go for promotion rank, so do custom sort and sort it with respect to the column C, which is has promotions from smallest to largest, and say OK. And then you can simply give 1, 2, 3, 4, 5, 6, 7, 8 here, which is the rank for promotion. Then the same data you again go for custom sort. This time you rank with F, which is attendance, and then go for it, and then you give 1, 2, 3, 4, 5, 6, 7, 8. This is what I have followed here, and then you will have the two ranks available. Now what is D square? D square is nothing but the difference in the ranks ka square. So you can simply do this D square here, and once you have this, you will have to calculate the sigma D square, which is 8 in this case. And then when you substitute in this formula, 1 minus 6 times sigma D square upon n into bracket n square minus 1. N is the number of pairs. So we have 8 pairs here. So you are getting this particular Spearman's rank or correlation between these two to be 0.9047. Okay, so this is one kind of rank correlation. The other one is Pearson correlation, which is directly available here. So what we will do, we will go to data, and in data you will go for data analysis, and then you will go for this correlation. This correlation gives you the Pearson's correlation. So in the input range we are going to put this entire range because we want a correlation coefficient between the two. Then we are going to click on the labels because we have the labels, and wherever we want output to appear. So for example, I have selected here, it came here. So if I select this cell, it will come here. So sorry, this is, I will come again. So this one is your range, and then where I want the output, I will use this cell as my output cell here. Suppose this cell, and then labels in the first row, and I say go, and I will get this value, which is the same value I am getting here. So this is how I will find out the Pearson's correlation, which is a direct function available in Excel. Now let us go to the simple regression. Now simple regression also is available directly. For example, I want to find out the regression between the regression function between attendance and promotion. So what I will do, I will go to data analysis, and then I will go for regression here, regression, okay, and go for it. Okay, now I am going to select input y range. Y is my dependent variable, so I will select this as my y coefficient. Then when I am doing simple regression, I will just select the another parameter in my x range, that is promotion, and I will tick mark on label, and output, suppose I want here output range, I will give here, I want the output to come here. Okay, and I will say OK, and I am getting this output here. Let me just transfer it here. Okay, so in the output I have many things. I have the R square also is available. The sum of square is also there. The mean square F statistics is there. Significance is very low. That means it is this particular correlation is regression is significant. But what is my regression formula? So regression formula can be written here. So I will write using these two values. I will write my regression formula. These two values is my regression formula. So I will write my attendance equal to, so I will write first equal to the intercept, which is 2600,382.37, right, plus, so my plus my coefficient, that is 0.257, 257 into multiplied by the promotion in dollars. So this is going to be my equation. Sorry. So I hope you have understood. So it is this. I will just write this equal to. So it's not a 26382.37. Okay, plus into bracket 0.2571 promotion in dollars, right? So this is going to be my equation, regression equation. This is going to be my regression equation based on these coefficients I am getting. So this is how we calculate, we use the simple regression. If I want it between means, I have to take attendance and means. Now let me show you the multiple regression with the same data. So now I want to find out the multiple regression, that is my y is my dependent variable, and considering these two are my independent variables. Again I will go for the same. I will go for data analysis, then go for regression, and in this my again my y range is this, and when I am writing my x range I will select both two cells together. So depending on if you have 3, 4, 5 dependent variables, all this you can put them together, but when you are putting it together they should be clubbed together. So they should be first arranged next to each other, then tick mark the labels, and output I want it somewhere here. Sorry, again I did a mistake here. So my dependent independent are this, sorry, dependent are this. Then for output range I am going to select this place and go for it. So here what I have got is, again it is a significant regression coefficient is significant. All the regression coefficients are, so this model is significant, and the model is given by these three values here. This is what we will use. So I will quickly write the equation. The equation will be like this: attendance for the upcoming match is given by, okay, I'll use this equal to, first the intercept 19094 plus into bracket wins 3560 multiply by wins, right? This is my first variable, then plus again bracket 0.0369 multiplied by promotion. So this is going to be my regression equation for attendance when I am considering both the dependent variables wins and promotion together to find out the attendance. So this is what is the multiple regression is all about. Thank you.